So I was telling you, so
Yes, sir. Actually, yesterday I was going through it.
IEEE 802 dot 2.1
Hmm.
W standard,
Yeah.
which is
Rapid
rapid
spanning tree.
spanning.
Hmm. Yeah.
Now, how this is faster than the normal spanning tree, which is called as
Mm-hmm.
classical spanning tree,
Mm-hmm.
IEEE
Yeah.
802.1D. In what way the differences or how
Mm-hmm.
IEEE 802.1W is faster
Mm-hmm.
than IEEE 802.1D? What is the change
Mm-hmm.
that is done? Okay, we need to
Yeah.
understand that. You see, in IEEE 802.1D, if
Mm-hmm.
I have switches like this, and there is a block here, and this is a root port, let us assume root
Mm-hmm.
switch. Let's assume this is
Yeah.
maybe this is root switch, or I'll call this as root port, root switch, and let's say there is a
Mm-hmm.
block here.
Yeah.
There's a block here.
Mm-hmm.
The reason why there is a block here is for this switch going this side is better
Mm-hmm.
because this guy's MAC address is smaller.
Mm-hmm.
This guy MAC address is big.
Mm-hmm.
So this is the root port and this is a blocking. This is a designated forwarding. This is the root port.
Mm-hmm.
This is root port. This is designated forwarding. Designated forwarding. Yeah. So now in our classical spanning tree, if this link goes down, or let me
Yeah.
make this, if this link goes down,
Mm-hmm.
this will be waiting for 20 seconds.
Mm-hmm.
20 seconds. After
Mm-hmm.
waiting, only then it will go to listening state.
Listening. Yeah. Mm-hmm.
And it will wait for 15 seconds.
Yeah.
Only then it
Correct.
will go to another 15 seconds of learning, which
Mm-hmm.
is not good for the real world. So what they did is,
Mm-hmm.
as soon as this switch know that this link is down,
Mm-hmm.
immediately it will shoot a topology change notification saying, hey,
Topology. Okay.
change
Okay. Got it. Mm-hmm.
notification message. And it will make the switch to immediately unblock. Where? In 802.1W.
Mm-hmm.
In
Yeah.
1W, it won't wait for the
Mm-hmm.
the time to elapse. It won't wait for the time to get over.
Mm-hmm.
It will simply change the role to forwarding as soon as
Mm-hmm.
it learns that from the topology change notification, as soon as it knows that the link is down. See, this switch number 2,
Mm-hmm.
as soon as it understands that the line protocol gone down, the link goes down immediately, line protocol will go down, isn't it?
Yeah.
The protocols cannot work. Immediately, the switch will say, hey, it will tell to this guy.
Mm-hmm.
It will tell to this guy, hey, I know you are blocking. So
Mm-hmm.
please unblock. And this guy will not wait for anyone else approval, like it won't wait for root switch approval. Here,
Mm-hmm.
it will wait for root switch approval. After 20 seconds, it listens for root switch
Mm-hmm.
to approve to unblock.
Mm-hmm.
Here, There is no such story. As soon as it knows that something went wrong, it immediately unblocks. So every switch in this topology knows that there is a block here.
Yeah.
And as soon as the other switches, like switch 3, comes to know that there is a break in the link, instead of forwarding the packet via this direction, they all will start forwarding via this direction because they know that this guy would have unblocked.
Understood.
So swapping of traffic happens immediately. Swapping of traffic. Earlier it was sending like this because there was a block. As soon as they understood that this is wrong, that this has gone down, the switch knows very well that there is one block would have been removed now, so let us send this way. Let us send this way, they all will send
So,
this way.
sir, one question, like this topology notification, it is sending using the BPDUs?
Yes, correct. Right, so it will be sent as a trigger as soon as the link goes down. It's an additional field called topology notification, which is going to warn, which is going to alert the alternate port to become a forwarding port. So, in a simple word, if I need to say the difference between dot 1D and dot 1W, the difference is this is that is what I can say. This is timer based. They wait for the timeout to happen and then only they decide. The rapid spanning tree is not timer based. As soon as it knows that there is a link failure, immediately the swapping of traffic happens to the alternate path. Yeah. Immediately the swapping of traffic happens through the alternate path. Yeah. So we have very fast convergence. Very fast convergence. It's not timer
One question,
based.
sir, like
So this is
other things like in every 2 seconds we are sending BPDUs, that is remain same.
those things
there,
are still there. Yeah. There is no change in that. But these guys won't wait for 20-second timeout or 15-second listening. See, they don't listen, but not for 15 seconds. As soon as they listen and learn that there is a change in the topology, they immediately unblock. Because they already know that whenever there is a change, I need to unblock. Whereas in normal classical IEEE 802.1b, it will not keep track. It will wait and then it will try to learn and then only it will unblock. Every time it will learn and then it will forget which one, the classical one. But IEEE 802.1w, it remembers where the block is. So if something is going wrong, where we should unblock. Yeah. So IEEE 802.1w is not timer based. As a result, this is rapid. This is faster. Now, Cisco designed a spanning tree which is not D. They took D and they modified it and they developed a protocol called her VLAN spanning tree protocol. PVSTP. I have not spoken about this PVSTP so far. I only spoke to you the 3 industry standard spanning tree. I only spoke to you the 3 industry standard protocol. IEEE 802.1d, 1W, and 1S, which we are going to speak. MST is S, isn't it? We saw yesterday. But I did not talk about this per VLAN spanning tree, which is Cisco's. Now, what is the difference between PVSTP and dot IEEE 802.1d? What is the difference? What is the difference between this? See, this is industry standard. That's one difference. This is Cisco.
Yeah.
Secondly, this is only one instance of spanning tree protocol for all VLAN. If I have 10 VLAN, how many spanning trees running? Only one.
Which means like per VLAN only one STP, right?
No. Listen. All VLAN.
Okay.
Whereas in per VLAN spanning tree, for each VLAN, one instance. So if I have 10 VLANs, how many spanning tree I will be running? 10. In Cisco's version of spanning tree, per VLAN spanning tree, is going to run as many VLANs as you have.
Yeah.
If I have 100 VLAN, then I'm going to have 100 spanning tree. What is that?
Yeah, what's that advantage?
What is that advantage? See, there is a big advantage and there is a small disadvantage. What is the big advantage? Let's see a small scenario. I have 1, 2, 3, 4. Now, this one is switch 1, switch 2, switch 3, switch 4. We got 4 switches. Now, let us assume I got VLAN 10, 20, 2 VLANs. And plus the default VLAN. What is the default VLAN number? 1. So there are 3 VLANs. Let's say another VLAN, 30. So there are 4 VLANs. If it is normal spanning tree, how many spanning tree instance will be there for
only
4
one
VLAN?
instance?
Only one. Now, let's say you got a block here. So all 4 VLAN traffic, see VLAN 1 people connected here and here. VLAN 2 people connected here and here. VLAN 3 people connected here.
10, 20, 30.
Sorry. 1, 10, 20 and VLAN 30 people connected here and also here. For all this 4 VLAN, The only path that is going to be taken is this path.
Yeah.
This is the only path for all VLANs. Even if the path is congested, even if the path is highly congested,
Yeah.
this is the only path it is going to take. So now, Cisco came up with an idea that because you are running only one spanning tree, you have this problem. For each VLAN, if you give separate instance, what you can do? You can go here and say spanning tree for VLAN 20 and 30 priority, how much? 0. What will happen immediately? If you make 20 and 30 priority 0, 1 and 10 will be going this way, 20 and 30 will start going this way. Why you know? Because the priority 0 means it will make this as a root switch, isn't it?
I didn't get that because the priority
Yes, sir.
of VLAN we are changing, right?
What happened? You are struck. You are struck. Wait a minute. Listen carefully. We have all these 4 VLANs running everywhere. All these 4 VLANs are running everywhere. For all the VLANs, this is blocking. Now, if it is per VLAN spanning tree, because there is going to be a separate instance of spanning tree on each switch, I can go to the spanning tree of 20 and spanning tree of 30 and change the priority to 0 so that this will become what switch for 20 and 30?
Root switch, yes.
Only for 20 and 30 this will become root switch.
Yeah.
For 1 and 10, the first switch is already a root switch, no change. So for 20 and 30, let me give one color. 20 and 30, there is going to be a block here.
Yeah.
For 1 and 10, there is a block here. So 1 and 10 will go this way, 20 and 30 will go this way. This is what? Load sharing. We are manually sharing the load. We are manually sharing the load across this path by setting the priority. So per VLAN spanning tree is very good because you can do load sharing. We can change the priority. By changing the priority, we can do load sharing. Right? Fine. So this is the advantage of per VLAN spanning tree. Now, when you enable rapid spanning tree protocol in Cisco, I'm not talking about other vendors. In Cisco, when you enable rapid spanning tree protocol, it is going to be rapid spanning tree per VLAN spanning tree plus. What is the meaning of it? You're going to have a separate instance of rapid spanning tree, not normal spanning tree. You're going to have each VLAN a separate instance of rapid spanning tree. For every VLAN, there is going to be a copy of rapid spanning tree, not normal spanning tree. This is not normal PVST. This is PVST plus, which means it is running along with RSTP. But you don't need to enable this. I'm telling you, if you enable rapid spanning tree, this gets enabled automatically. You don't need to say rapid spanning tree should be running for every VLAN. You don't need to say that. It gets enabled automatically. It gets enabled automatically as you enable spanning tree, rapid
Mm-hmm.
spanning tree. The per VLAN spanning tree gets enabled automatically. So that's rapid spanning tree. Rapid.
Mm-hmm.
Rapid per VLAN spanning tree.